Hi everybody, welcome back to the second class of the track number 6. My name is Anibal Azevedo and now we are talking about how we can apply artificial intelligence techniques to some container port operations logistics. So now we're gonna talk about how we can use the previously codes. We're gonna see the previously codes that we defined in previously tracks, and how you can use this code to adapt the previously simulator that only was able to solve the container ship storage problem. So let's see how we can do this. So let's see the code. And remember that in the description of this video, you can find this code, okay? So here is the code. So let's see here. We have the code that we defined in track 1. We already loaded this code. So this code is important because we can see the container ship class. Remember, okay? It's defined here. So with all this, we can use the container ship class, and also we cannot use the unloading and loading rules that have been defined in track 2. And in track 3, you have the port simulator. That means the container ship travel through ports and how to compute the total number of movements. You can get this by using this port simulator. As you can see here, the code is not extensive. You can load all things by just clicking here, play, okay? And you must load in this sequence. Okay, now we can have many uh, solutions to simulate. We can evaluate many solutions because we have a combinatorial problem related with the number of rules that we can apply in each port. So here we have defined the GA class that is interesting to test to improve the random solution. Okay, so finally, we in track 5 in the previous track have defined how two Quay crane rules, how to operate two cranes, and compute the total time necessary to perform our workload for loading or unloading operations. That's an important issue here. And finally, we get here the code of this track. That's important. We get here. So let's see in more detail. I'm gonna get a zoom here because it will be impossible to understand anything without a zoom. So we used again the strategy of naming the tuple that we applied, that we defined for in track 3 for its simulator. Instead of using a giant number of parameters, we can, okay, that's not good, okay. We can use this Quake crane simulator parameters. So it will be minimal distance and time to move a crane to another bay, okay. This is important because instead of passing many parameters for the simulator, the quick range simulator, you pass just this name. We're gonna see this here. So here we define the Quake Crane container ship dimensions, the number of bays, the number of lines and rows, the rows and columns. So also we defined the number of unloading rules functions that we have and the number of loading rules that we're gonna be used, and also the number of Quake Crane rules that we defined. So these are the total number of the product of these integer numbers will get will lead us to the total number of possible rules that we can apply in each port. So for many ports you get easily a combinatorial problem. Okay. Additionally, we got this variable, okay, and because this is the number for the unloading, loading, and Quake crane rules, okay. So this is the transportation matrix that we explained in the track 3 when we need this information of how many containers will be loaded in each port. for each port, for example, in port 1, port 2, and which are the destination, how many containers, which destinations, port 3, 4, and 5, and so on. So this is the variables because we are interested to see some messages. Okay, we pass this to simple run, and this is the parameters of the simulator, the class that simulates the container ship storage planning problem. Also, this is the problem that we are adding a new layer here because we are just trying to understand or to see how much time we're going to spend the ship in each port. So we need to define this another simulator that will consider all the developments that we made in this other simulator. Okay, so the key feature here is how to combine the previously simulator that we made in track 3 with the new simulator that we're gonna consider the Quay crane operations. And what we done here, we considered the number of ports. It's important because we will define the number of places of the list, which means which room will be applying each port. Okay, this is the solution. So we can create the solution and evaluate this solution by using this evaluate solution. It's important to see that we define this variable, which is an object of this very crazy name simulation class. And remember that we used this parameter, okay, and this solution. So you can think about that it's missing something, something's not right because we are not accounting the previously simulator, but we're gonna see how we are accounting this. Observe that first, it's important to have this new function, and this new function will be related with the container ship class. Why this function is important, why we are adding this new method to the container ship, because this new method is able to see inside the cargo map field and see how much extract, how much workload will be necessary for each bay, depending on unloading or loading operation that we're gonna make. Okay, so this is an important method that we are adding to this container ship, and what we see that we do this inside this new simulator. This new simulator it's a container ship storage problem simulator, and it will inherit all the methods from this simulation. Okay. Also, what is important, we add some new parameters, the parameters that are related with the Quay crane's operation. So we use this to use the parameters from the previously simulator that we defined in track 3, and also we use these new parameters because these parameters will be important to compute the total time. So what more, we using this inheritance mechanism, it's important because you can avoid to do redefine all functions. The only function that you should redefine is this evaluate, because it will be in a different fashion. So why? Because we have these two other parameters, and we added what more we have added here. We have added this translate to norm rules. This is not new, but what is new here is that function, and this function computes how much workload will be necessary for each bay before unloading operations. Okay, after doing this, we compute this again and see how much workload we have in each bay after performing unloading operations. So the difference of this list and this list will get us how much workload will be necessary for this unloading operation method function. So rule in this case. So we compute this, how much workload will be necessary for each bay, and apply now the Quay crane rule. So this Quay crane rule is exactly here. So it's you use a combination of numbers and names here. And finally, you can apply the Quay crane rules that we defined in track 5. Remember this Quay crane rules here. Okay, move Quay crane 1. So we applied exactly here, depending of the encoding that we made or the number, integer number that have been decoded. We can get different move quick crane rules here. We applied here, and this is important because we got this total time necessary to perform the operations using this quick crane rules, this quick crane rule. Okay, so you can get the number of movements, also the total time necessary to perform unloading an operation and loading operation rules. Okay, so what's important here, we applied this scheme of computing how much time is necessary to unloading or to loading operations. So that's it, the difference between this simulator and the simulator that we defined before. Nothing else more. So so you can use it, all the developments. As you can see here, everything works correctly. We double check it, triple check it this. Okay, so in the verbose modes, I know that it's not good for comprehension, but you can test the code. This code will be available in the description of this video, so you can see, you can test. And I know that it seems too simple to be true, but it works. Okay, and what is much more important than this is important to see that if you are trying to add a new layer of equipments or simulations, you can encapsulate the simulations. You can create simulations inside simulations to get new things or to have new behavior. And this is an interesting way to use the previously work made on previously simulators. So this is the strategy that we use here. It seems to be very effective and to be very understandable. I know that's not simple, but after you understand the mechanism, you can get very interesting things by using this. Okay, so this is the end of this track. It will be very short because we are using the previously developments that we made, the things that we discussed in detail in previously tracks. So now we are using a fast way to discuss ideas because I believe that you learn everything that we talk about in previously tracks. Okay, so the next track will show how you can use all this modification that we made to consider Quay crane. Now we have to change also the genetic algorithmic class to consider what, to consider this Quay crane rules. So it will be very simple. It will why we are doing this little modification in genetic algorithm, because it's not just a question of using a simulator. It's just another question, an important question, because now we have two objective functions. We have the total number of movements and total time spent. So we have to combine them. Okay, so how we gonna change the genetic algorithm to consider these two objective functions? We're gonna see in the next track. Okay, it will be also a fast track, not too much things to say in the next track, but important things. Okay, so see you in the next track. I hope you find this video interesting and useful. Bye.